Everyone, and welcome to today's webinar on MV and HV circuit breaker testing. My name is Sanjay Yadav and I'll be hosting this session today. Speaker for today's session is Mr. Ali Hussain, who is an application engineer at Mega Middle East. Before handing the mic over to Mr. Ali, I would like to highlight a few points. You all are being muted to avoid any disturbance during the presentation. Do park any question you may have for the Q&A session at the end or share it in the chat window with the presenter. All questions will be answered at the end of the session. We have an Mega exclusive page on Facebook and LinkedIn. I'll just share that in the chat section. You can follow us on Facebook and LinkedIn. We also have upcoming webinars, which I'll just share in the chat section. So you can go on this link and you can register yourself for the upcoming webinars. Also, there will be a small survey form at the end of the webinar, so please do fill the same for the feedback regarding the webinar. The recording will be sent to you in 2 working days through the WebEx system and the presentation. I now hand over the control to Mr. Ali. So let's get started. Over to you, Ali.
Thank you, Sanjay, and welcome everyone. Good morning, good afternoon, good evening, wherever you are. Today's session about MV and HV circuit breaker testing is full with new and improved technologies to do testing for these types of circuit breakers. Before we begin, I would like to highlight that if you have any questions, please feel free to ask this question in the question pane. It will be my pleasure to answer any question that you might have at the end of the session. As for our agenda today, we have quite the agenda. We'll talk firstly about conventional circuit breaker testing, how it's done as a setup, as results, how to analyze this result, and also then we will talk about improvement that we can do for this conventional testing, starting from how to do it safely and also sometimes even faster or easier than the normal conventional testing, and some improved or special tests that you can do that can help you or give you more information than the conventional testing, like first trip test, and also dynamic resistance measurement, or what we refer to as DRM test, and see how and where these are applicable as tests. And in the end, I will talk briefly about medium voltage GIS systems, how to overcome the difficulty in testing these types of circuit breakers, since you have very limited access to the termination of these type of the breakers. And in the end, I'll talk briefly about some of the solutions that we have and offer, and close the session with answering any questions that you might have. So without further ado, let's start with some background about conventional CV or HV and MV CV circuit breaker testing. So when we talk about medium voltage or high voltage circuit breakers, what do we refer to? Usually we refer to anything above 1 kV. And usually these breakers are not operating on their own. They have a protection device that is issuing the trip or close commands to them. So they have a mechanism that's being operated by an external device. We'll see how this mechanism can be tested, how this contact system inside these breakers can be tested and checked as well. So the first picture you see here, this is a medium voltage circuit breaker where you can rack it out of the panel completely and do all kind of testing to it, doing the conventional way. Usually it's available in the distribution networks. Then we have a stationary one where you cannot remove or rack in or rack out the breaker. We have the old, now obsolete, also oil circuit breakers or bulk oil circuit breaker. This kind of circuit breaker are still available in some regions and some countries, but nowadays are usually being replaced by SF6 type circuit breakers, where we have the live tank circuit breakers or dead tank circuit breaker, where the tank or the body is grounded, and it is preferable usually in areas where we have earthquakes or events like that, that having the live tanks is not something very safe. And then you have some hybrid system where you have GIS and open air insulation system as well. Usually they are outdoors to save a little bit space as well. And then you have, which is the most common in our region for at least high voltage system, is full GIS systems, where you have all your switchgear, bus bars integrated into a gas, usually SF6 gas. And also nowadays you are finding it new having medium voltage systems or distribution systems as well as in GIS as well, not just like the rack in rack out system. In the end, I will speak about this and talk how we can test this MV GIS systems. So all these types of breakers, we consider them under the MV and HV circuit breakers. How we can test them? We test them using circuit breaker analyzers. What is the circuit breaker analyzer basically are? They are usually, you can see like an oscilloscope that can measure times, measure analog values, any contacts, auxiliary contacts, motion or analog motion using transducers for that, can measure voltage and current for example, the control circuitry to verify that the control circuitry, like coils, the windings in there, all are working correctly. As well, in some circuit breaker analyzer, there is also some digital channels where can measure a different number of things. So all these functionality available depending on the circuit breaker analyzer that you have. There are some low-end ones and some high-end ones that you can use to do a lot of number of tests that we will speak about in a very short time. So if I want to do, for example, a simple breaker testing setup, if I have, let's say, a dead tank circuit breaker like I have in the picture here in front of me, this dead tank circuit breaker, usually when I want to do any testing setup as a procedure, first I will open the breaker. Once I get my permit to do any maintenance or testing job, I will open my breaker. And then after opening this breaker, I will isolate the breaker using my isolators before and after. And then in order to start doing any connection work, I need to make sure this is a safe area. So I will connect grounds usually to both sides of the breaker to create a safe zone for me to work. Anything after that or before that will be a non-safe area to work in. Then I can bring my circuit breaker analyzer. In this case, we have the TM1700. And I will connect my control circuitry, the close open coil. I will connect my timing leads to each phase. If I have multiple break per phase as well, I can do that. And then once I do all my connections, I will remove one ground from one side, and then I can start testing. The reason for removing that ground is because in the conventional way of testing, usually the circuit breaker analyzer do a continuity test. If you have two grounds or both sides grounded, you will always have a short circuit to the ground, and that continuity testing will not be valid. So when I want to do a testing now, the continuity tester or continuity measurement will detect for me the open and close condition according to this criteria, and then I can get the timing value. In this case, it's like 55 or 50 something millisecond. So now I can do multiple operations like close, open, and high voltage circuit breakers. Usually you have a double or triple operation where you have close, open, or open, close, what we call switch on to fault, or reclose operation. And also we can combine both the double operation, and we get open, close, open, what we call reclose and switch on to fault together. Once I do that, I will find some results. For example, this is a coil current result and also a motion measurement result. These results, once I can find them or once I acquire them, I can compare them with the reference values that coming from the factory acceptance test, and I can compare them also with the standard or between phases, phase versus phase, that they have very similar time between the phases during the close operation or the open operation. If I have multiple interrupter per phase, usually this is in very high voltage, 400 kV and above, I can compare between each interrupter within the same phase and make sure they are opening or closing with a very small difference between them. This is not usually available in our region, but if you have resistor contacts or what's called pre-inserted resistance contact, you can compare their times as well to check that. And at the end as well, you can check the auxiliary contacts, ready to close, ready to open, or what we refer to as 52A and 52B, and check them. And once I find the comparison between the reference values and my test values that I did now, I can compare according to this table. If I have any slower or faster, there are number of problems that I can detect from that. Now, usually from what I see within our region, it's usually just the timing test that is usually done. But the standard actually not only does timing test or recommend timing test, but timing and the travel at the same time. The travel test or motion test, what we call it, it's very, very important to be done. It gives you more information than the time, because the timing test, once the contact touch or untouch will end, after that or before that, you have no information about the condition of your circuit breaker. That gap or loss of information can be filled with the travel test. So it is very, very important test to do. I have two case studies to show you or give you why it is important to do a travel test. So the first case study about a travel or motion test is that there is a failure in the dashpot, the unit that holds at the end of the operation or the end of travel for the contacts. It stops the movement or absorb the movement. It has a problem to it, and it's shaking very, very harshly. It is bouncing a lot. Within repeated operation, this could lead to a big failure in the circuit breaker or the mechanism of the circuit breaker. So they did just a timing test, and the result was normal, fine. But when they did the motion test, the motion, which is in black here, has shown huge bouncing at the end of the operation. The maximum rebound, this is the parameter for this bouncing at the end, should be 5 millimeter, but it's much exceeding that value. So they did adjust this dashpot, or let's say over adjusted it, and did it the test again. The motion has become now stable at the end, but it is under traveling. It's not traveling the full length of the contacts. It was 109, now became 104 millimeter, which is another problem. So they readjusted again, and they got a very stable result. Now, within all these three adjustments, before and then the over adjustment and then the correct adjustment, the timing test parameters did not change. They always give 19.3 millisecond or 19 something millisecond. So with all these changes, timing test could not detect this problem in the circuit breaker. Why? Because the timing test only gives you information at the disconnection of the two contacts from touching each other. This is why travel test is very important. Another case study number 2, they did a timing test and everything seems okay. But when they did the motion test as well with the timing test, they found out that phase B is moving faster than phase A and C, which could indicate a problem or excessive force applied on phase B mechanism. So after adjustment, the phase B motion, which is the yellow one, has become aligned with the other two phases. Now, before the adjustment and after the adjustment, the timing test did not change. So this problem can only be seen or only be detected by doing motion test. So in conclusion, travel test, it is very important test. The standard recommends it. The information that you can get from travel test is much, much more than just doing timing test. So it's definitely worth doing. If you want to find out more information about that, I have done a webinar 1 month or 2 months ago specifically about the travel and motion test. I would recommend you to go and see that webinar explaining more details about a travel test. Now, moving forward, this is what conventionally been done for many, many years. How can we improve upon that? How can we make things safer and faster as well? If you remember from my previously when I was explaining a normal or conventional setup for a timing test, there was a requirement to remove one ground from the both sides to do the test. Now, if you do that and you have any live conductor near your circuit breaker, this is usually a true case in maintenance jobs, maybe not in commissioning, but in maintenance, you definitely have something energized in the substation. You could get induced currents from nearby conductors. And as well, you can get any capacitive coupling from if you have overhead lines or you have an adjacent bay to it. All of these things could contribute to certain problems or certain dangerous zones that can be created. You can get electrocuted, you can get burns from these induced current and voltages. And actually, we got some test equipment unit or some circuit breaker analyzer being sent to the factory for repair because the channels in them got burned because of these leakages that coming in. If let's say you are testing, let's say a 220 kV a line and you get 1 or 2% leakage, that's like 2 or 3 kV, which is something very dangerous. So doing conventional timing for these high voltage situations, it's not something recommended. If only we can do the test in even safer way by doing the test in a dual ground. Resistance, and when you have both sides grounded of the circuit breaker, the resistance measured will be the earth resistance, whether it's open or closed. So it will always show you short circuit and it will not work. So that's why Megger have developed the dynamic capacitance measurement method, specifically for the dual ground circuit breaker testing. The DCM method, or dynamic capacitance measurement method, it's basically like the SFRA test that they use for a transformer. The circuit or the circuit of the circuit breaker in this case, it will be like a variable capacitor that is changing depending on the status of the breaker, as it's open or closed. And we use that with combination of a variable frequency source that change the frequency to tune in to a certain frequency when the circuit breaker is closed, to detect when the breaker is closed or open. And with this detection, at doing it at a high frequency, we can test the breaker for timing test while both sides are grounded. Thus, we are in a very safe zone. And if you compare this with even a conventional timing test, it will give you a very accurate results. I've been doing this more than 10 years from now. It's been developed since like 15 years. This method and been used in many places, been used with outdoor circuit breakers as well as for GIS as well. So you can do a dual ground timing, and it's not only going to make it safer for you, but in some cases, in many cases actually, can be even faster or easier. I know a personnel who was doing conventional timing for GIS systems, and he needed to remove ground and that GIS system. It took him like 2 days, just 1 day to remove the ground, and after finishing the test, another day just to reconnect that ground and all that alignment job and all and on. Because his GIS system was designed, the ground was designed in a very certain way. Now, with doing dual ground timing test, he did not have to remove that ground, and the test can be done in just a few hours. So it's really not just it is safely done, but even efficiently. So dual ground is always something we recommend to do instead of doing conventional timing. Additional application that can benefit heavily from dual ground if you are testing, for example, generator circuit breakers. Usually their groundings are very big. You have a lot of links. If you can see in the picture here, we have like 16 or 18 link that need to be removed from ground to be able to do conventional timing. With dual ground timing, we don't have to remove that. Another application is for GIS system. It can really, in many cases, save you time doing it dual ground than the normal ground. In a couple of weeks, I will be talking specifically about GIS testing. So please go register in that webinar to get more information about this. And if you have a transformer base where connecting is difficult, this also can help you by connecting to the ground of that transformer to test the GIS system as well. We have some cases that dual ground was the only way to test that circuit breaker. Even conventional timing was not applicable in that cases. So this is one way to improve or to add on conventional timing. Another way is as well to add on or even get more information is doing what we call first trip test. This test, you first have to understand why it is an important test, the first trip. The breaker could remain in a closed position for months or even years without any operation. But suddenly there is a fault in the line or in the cable, and you need that breaker to operate. So staying not operating for a very long time could have some built-in dust, rust, and other things. You have bad lubrication in the mechanism that for that first time of operating, the breaker takes a little bit longer time than the normal operating time. So this comes where the naming comes, first trip test. This test, it is a test that's done to the breaker while it's online, while it's been in service for a very long time, to capture the tripping time of that breaker in this situation. When you are doing conventional testing or conventional timing test, usually you will have to open the breaker for the first time and then do all the connection that you need, isolate, do the connection and remove ground, all that. Valuable information is lost because you operate it for the first time. The mechanism could get a little bit re-lubricated, so that information is lost. That's why we recommend doing something called first test or first trip test before doing conventional timing or a BM test. You can do this to get that information, and it's a very basic and simple test to the breaker, really. So this test can be started first by just recording the coil current and coil voltage and comparing it with the reference coil current and see if there is any difference. And if you can see from the picture here, I have a difference in the second jump here. The blue one is the reference one and the red one is the first trip test after a very long time of no operation. You can see that it takes a little bit more time for the current to drop, meaning that the mechanism of the breaker is a little bit slower for this first time. And this is a real case that could happen in real application. You have your protection system not operating for, I don't know how long, 1 year, 2 years, and then suddenly a fault happen, that breaker operate, and it takes additional few milliseconds because it got rusty, because it got bad lubrication for a very long time, and that information is lost if you don't do that first trip to see is it going to operate as after a certain maintenance, or even during a long time, is it going to operate the same or not? So there are really two setups to do first trip test. The first setup is the easier one, just connecting to the control circuitry. You connect a clamp to measure the coil current. You measure the control voltage during the first operation, like the DC system voltage. And you take a trigger from the control to trigger the test equipment to start the measurement at the start of your breaker operation. If you want as well, you can measure the auxiliary contacts as well. Now the second setup, which is even better than the first one, in addition to everything you did in the first setup, like the control voltage DC and the coil current and the trigger, you also utilize the CTs available in this bay while the breaker is online. And for this test, you have to have a load at least going through the breaker. So you can connect 3 clamps to each CT and measure the current as well. And from that measurement, you can get the current in each phase. When it will become 0, means the breaker has opened. The voltage measured, or the DC voltage, there is any dip in it or anything, and also the coil current. So this is the coil current, the control voltage, and the CT current measured from the secondary side. This information can give you, especially the coil current is very important in this case. You can see the maximum currents going through the coil, the timings, the start time, end time of the part in the coil, and also the part in the mechanism. Between the stop time of the armature and the auxiliary contact opening, this is the time your mechanism takes to operate the breaker fully. If this time is longer than the previous or reference time that you get from the factory, then your mechanism has a bad lubrication, maybe with a little bit rust or dust built in inside, that maybe need better isolation of the mechanism or insulation of that. And this is an example of a comparison between coil currents. This is reference one and a first trip one, and you can see there are some difference in timings. Here, the mechanism time, the second jump, higher jump, is very similar to the time from the first trip to the reference, but the armature time, the coil time itself, have a huge difference between them. This means you have a bad lubrication not in your mechanism of the breaker, but in your control circuitry or in your coil itself. So you maybe need to check that, lubricate it very correctly to see that. This is information that can be only given by the first trip test. Have any problem in that, you can see them here. Another thing as well is your voltage. You can see if there is any huge dip in the voltage during the operation of the breaker. You can see if there is any bad, maybe a DC system or inadequate for this application, can be seen by doing the first trip test. So first trip test is really having an advantage of showing you the real life trip time of the breaker, especially if it's not operated for a long time. If you have any lubrication corrosion problem, can be detected by this, because when you do normal conventional timing, during, for example, preventive maintenance or PM. Usually everything is being cleaned and all of that and done. Then you do the test and everything becomes fine. But if you want to see the real life time, you have to see it like this. So it is really recommended to see or do first trip, especially for breakers that have been in service for a very long period of time. Another thing that it's very important to see is the motor current or spring charge motor current. This spring charge motor current as well can be measured by using multiple circuit breaker analyzers. It's basically just connecting a clamp to the coil current and observe the current, how long it takes to fully charge the spring, and what is the maximum current taking it for that motor to see that it's not exceeding the time or limit of the current as well. Another additional, or I would say an advanced test that you can do for circuit breakers, especially the SF6 circuit breakers, is dynamic resistance measurement, or what we call DRM. In the SF6 circuit breaker, the contact system is usually comprised of two contacts. You have a main contact, you see it on the around the breaker, which is used to conduct the current or the load current or even through fault currents for the specified duration when the breaker is closed. And then you have an inner two contacts called the arcing contacts, which is used to absorb the arcing or flash inside the circuit breaker interrupters during opening or closing the breaker. So these arcing contacts, when we're doing normal contact resistance test for them, you cannot measure them because they have a higher resistance than the main contact, and within few short circuit interruptions, these contacts could wear out. So how can we verify their condition for that? Now, when you're doing even conventional timing, there is a little bit differentiation between the main contact and the arcing contact. You can't really detect that very well. Even for contact resistance, the same thing. And arcing contacts are usually the contacts that absorb this high current or high flash or high temperature arcs. So the only way to check them or to verify they are not being weared out is by doing a visual inspection. Now, doing a visual inspection in the circuit breaker require you to fully open it. So it is really a tedious job and very time consuming, and I don't think a lot of people really does that. So is there any alternative way to check these arcing contacts? Yes, there is. And the solution for that is dynamic resistance measurement, or for short, we call it DRM. It's basically doing a contact resistance test in combination with timing and a travel test. All these tests together. I'm doing a contact resistance while opening or closing the breaker. It's not only when it's closed, but during the operation. So a basic setup or a simple setup for that is we use the circuit breaker analyzer with a special contact resistance tester, or what we call accessory from our side called STRM. static and dynamic resistance measurement box, which is basically just like a super capacitor that can release a high current for a short duration, the time that I need to open or close the breaker. And once I do this test, and by the way, we can do this test even in dual ground conditions, so that's an additional safety for us, or less work in some cases. Once I do this test, I will get a graph like this. Now, since I'm doing a contact resistance while the breaker is opening, it is really difficult to get a number because the value is changing as the fingers or as the contact move away from each other. So, but what I get is I will get a graph like this. I have motion measurement that indicate that the contact are moving. I got small increases in the resistance value as the contacts open. This is an open operation. Once the main contact fully open from each other, only the two arcing contacts are touching each other, I will have a sudden jump like this jump in the middle here. This indicates that I have only, for this small time from 22 to 26 millisecond, I have my two arcing contacts touching each other. Now, how can I benefit from this? I take this in combination with the travel test to measure the length at which these two arcing contacts are touching. So from the start of touching of the arcing contacts till the full open of the breaker, the movement measurement in millimeter, the difference in between them will give me the length of my arcing contacts. If I did this test like 2 or 3 years, or at the acceptance of measurement or acceptance of factory acceptance of this breaker, and then after a few short circuit interruption, I did this test again. If there is any wear in these two contacts, it will be shown in this length here. It can really help you get this information without the requirement to open the breaker to visually inspect it. So here an example of a GCB, a generator circuit breaker, where they did this test before a short circuit currents. The length of the arcing contacts was 15.4 something millimeter. After number of short circuit currents, the contacts started to wear, and they did the test. They found out that it became 7 point something, almost half for the arcing contact. So a difference of 8 point something millimeter. Now, after seeing this using the DRM test, they decided to go and open the breaker. And this is a comparison between a spare arcing contacts and the one that got worn out. You can see there is a difference between them. There are some wear out available there. And this is what the DRM test was confirming as well. So it is a very interesting and I would say an advanced and special test, but it really can help you benefit or reduce a huge amount of work without opening the breaker. You can verify the arcing contact condition. Then, and last but not least, we have the topic of medium voltage GIS breaker timing. How can I test these breakers? Usually these available in distribution systems in very dense areas where you have very limited space, they can become really compact and useful in that cases. But due to their compactedness and it becomes really difficult to do conventional timing or even the dual ground timing if we want to do that. It's just difficult to connect to them. There is no terminals that you can connect across the breaker to do the timing test. You have to open the whole assembly, and that's a very tedious and difficult job. Luckily, a lot of these GIS system or medium voltage GIS system have a voltage detection system, or what you call VDS. It's usually used to monitor the voltage, check the system voltage healthy or not. But now we can also use it to do main contact timing by measuring this VDS system. There's a small accessory that you connect to this VDS system, and you can measure the timing from there. It will give you a very roughly accurate timing like the normal conventional timing. But there are some things to look for. The breaker must be live. There has to be a voltage presence, but this should not have any load current in it when you want to perform this test, since any load currents could introduce some arcing or something like that that will give you a little bit errors or measurement errors during the test. And also, luckily, other operations can be performed simultaneously, like the motion test using a transducer, or coil current can be done as well to these medium voltage GIS systems. This is a comparison between a conventional closed and open operations and a VDS operation. The VDS, it will not show you a big line indicating that the breaker is closed, but it will show you voltage instead, meaning that we have voltage in the VDS system. If you are interested in something like this, please contact me and I can give you more details, because I know there are some people who having difficulty doing this to these type of installations. I would like to thank you very much for joining us in this webinar. This is a closing session. Just a quick summary about what we have talked about. Circuit breaker analyzers can really give you ability to do basic or advanced testing. Doing conventional timing might not always the best option for you. You can have other options like the dual ground, the VDS timing for the medium voltage GIS systems. First trip could be beneficial, so there is a lot of options that you can do. It always something we recommend to go for the most safest and faster ways. So dual ground is something I really recommend. But another thing as well I would recommend is when you are accepting any circuit breaker, if you are a utility or an end user of a circuit breaker, please ask for all the information from the manufacturer, like the travel test, the coil currents, and all this information. So when you want to do this test, you have something reference you can compare between it. And this is some of our circuit breaker analyzer. We have the Eagle, which is a very famous device. It is still one break per phase. It's the most go-to circuit breaker analyzer for medium voltage systems. Then we have the TM series, the 1700 and 1800, which is usually are designed for high voltage, where you have multiple or separate mechanism for each phase. You have one mechanism, or you have multiple break per phase. These are the circuit breaker analyzer to go to for doing this testing. And these are the only two that can do dual ground. The Eagle cannot do dual ground for you. So thank you very much for joining us in this webinar. My contact email is available on the screen in case anyone would like to send me anything or any inquiry, would like to have a meeting to discuss anything in detail. It will be my pleasure to do that for you. Now we will go ahead and answer any questions that we have. Sanjay, is there any questions available for us to answer?
Yeah, so we will be waiting for 2 minutes for any Q&A to arrive. So
Yeah.
participants, please share your questions so that Ali can answer on the same. So we'll be waiting for 2 minutes.
All right.
Yeah, Ali, we have one question.
Okay. What's the question?
Is there in the chat section?
Oh, it's in the chat section. What is the question, Sanjay?
Yeah, the question is, when can we do this test if there is a problem or before using the circuit breaker?
When can we do this test? Which test that you are referring to, Sanjay? Or
Mention it clearly, the question. I request Mr. Mushri Al Farwan to resend the question. Okay, he's asking for MV and HV circuit breaker testing.
you mean like in a general test? Circuit breakers, I think, really depends on the standard followed by the utility or the user to when to do these testing. Usually, I don't believe it's more than 2 years. A test should be done to these circuit breakers. And I know some utilities that even every year that they do this preventive maintenance, and part of that preventive maintenance is doing timing test contact resistance, for example. So yeah, it really depends on the standard applied in your country or in your utility to do this testing.
Okay. Also, I request participants to put the questions in the Q&A panel so that you can directly.
They are sending you in the chat.
Yeah. So yeah,
Okay.
we request participants to send the questions in the Q&A box so that we are able to see the question.
All right. I see something in Arabic written. Can I get a copy of the lecture? Yes. I think in 1 or 2 days, the recording will be
Yeah.
sent to you.
Yeah, the
And
recording and presentation will be sent to you in 2 working days by the WebEx system.
also will try to maybe share the presentation with the participants after this session if needed. I see a question in the Q&A session about dual ground. Is dual ground for overhead? I'm not very sure about the question you are asking. Are you asking dual ground only for overhead line? Dual ground testing, we can do it for outdoor circuit breakers where you have overhead lines, and we can do it as well for GIS system. So for both GIS systems and also outdoor live tank or dead tank circuit breaker, dual ground is applicable. For GIS system, however, there are a few things might be additionally required, mainly something called ferrite. In order to get more information about that, I will be having a similar webinar 2 weeks from now on the same day, today, Tuesday, and I believe also at the same time, talking specifically about the GIS system circuit breaker testing. So please make sure to register in that to get more information about that. Is there any other question, Sanjay?
Yes, but I think I need to check the chat system. So this time. Okay, there is one more question from Mr. Mushri. This kind of test figure out the problem with fix it the problem or not? I don't know the.
I'm not sure if I understand that.
Yeah, dear participants, if you can share the question in the question and answer box
Yeah,
tab,
that would be
and
easier, but
also, yeah, please share the questions with the full details so that we are able to answer on it.
as for the question being asked, if you go, for example, to any doctor to have any problem or just to check up, they will do a number of tests. This is similar to that. You have to do a number of tests on circuit breakers to verify their mechanism is working correctly, their contact system, their insulation inside, the control circuitry is having a healthy voltage, healthy current going through the coil to energize the coil and release the mechanism. All these tests, if there is a problem in it, you can verify it by testing. So yes, you definitely need to do most of the tests that I have mentioned here. As for the advanced tests like the first trip or the DRM, it's really situational. For the first trip test, it is something we recommend after the breaker being in service for a very long time that you do a first trip test. And for DRM, we recommend to do this test after number of short circuit currents and only for SF6 circuit breakers like live tank, dead tanks, and GIS systems. Other than that, it's really not very applicable because the contact system will be different. For example, for air blast circuit breakers, or if you have the old oil circuit breakers, or even vacuum circuit breaker and medium voltage system. Is there any
So
other questions, Sanjay? I
no,
believe we are out of time.
yeah.
I don't want to exceed the time of the participants. I'd like to thank you all for joining us in this session, and I hope you all have a good day. Goodbye.